it might be interesting for you guys to see how we dealt with it and how it went. So as this talk is about migrating data between clouds, this is like a good point to actually ask you what do you guys use on your project, where do you host your applications, and yeah, so you will have some basic information about like what is the what do you guys do. So there is this poll, you can see it now and answer it. And while you answer, I'll just go quickly through the through today's through the plans. So we'll start with a quick introduction about the project and what was the assignment that we got from boss and what was necessary to do. Then we'll go through the implementing of through the actual implementation of the solution, and also like what issues and challenges we faced. And yeah, then we'll take a look at lessons and some takeaways that we learned during the migration and how it all went. And then in the end we will have some time, I believe, for questions and answers, and also for some little discussion. So I just want to encourage you guys to post your questions in chat if you have any, and we can discuss it later after the talk. So, please feel free to answer the poll. All right, cool. So I think we can move on. And so, like I said, we'll start with a quick introduction. Basically, what we're going to talk about today is R2 apps, Search, and Grizzly. These are like dating apps for LGBTQ community, especially for guys. They both started as an internal project here in STRV, and after some time they evolved into a full product that's been in production for a couple of years. I think Search has been in production for like five years, maybe even more, and Grizzly something around 3 years. So as you can see probably and guess, it's not a startup, I would say, or a project without a real user base. So there's actually a lot of users active on those platforms, which bring challenges when we want to do some some changes in the infrastructure and so on. So yeah, we started on Heroku. For those of you who don't know what the Heroku is, it's just a really simple way of deploying and hosting your apps on the internet. It's really easy, and everyone can start like in no time with it. And we also use Postgres as our relational database for storing all user data. And this is also we also use Firebase for some real-time updates for mobile apps, and also for chat feature, which is like usually a part of dating apps. Yeah, so data was originally stored in Microsoft Azure, which is cloud provider, the same as Amazon, AWS, or Google Cloud, for example. And it's been in Azure since the apps were built. So it's been kind of like legacy code, because, like I said in the beginning, I've been in production for a few years already. And as time was going, we faced some like business requirements, or some changes were necessary. And also some new features were coming along, right? But we at STR we usually prefer AWS or Google Cloud as our cloud provider, and not many people actually have an experience with Azure. So that's why it's kind of like legacy. It's kind of like legacy because our engineers don't really have much experience with it, and also it was like kind of like shady in some places. We didn't really know what was there and how it was all working together. And also the other very important reason for migration was the price. I uh, I I think that was like the main reason actually to decide to migrate everything to AWS. And yeah, I think why would we want to migrate it directly to AWS is because well you can obviously choose some other platform, but for us it was like maybe the most popular option I would say. And also we had some new things that we were building already deployed in AWS, so we wanted to have it all under one roof. So. Yeah. Yeah. So what was actually needed to migrate? There was a couple of things that were stored originally in Azure, and we had to move them to AWS. So I think we could start with schedulers because it's like it was really really easy change. Usually, well, originally schedulers were designed in a way that you would have a HTTP endpoint at your API, and then you would set up or configure a scheduler in Azure, and you would set up like time at which time the Azure should ping your API endpoint, and this way it kind of worked like a like a scheduler. But this is like kind of complicated and I think like complex necessarily. So we decided to refactor it in code, which was actually pretty easy and straightforward. So yeah, basically we got rid of one of the Azure dependencies, and we didn't introduce any new dependency, let's say. So that was pretty easy and straightforward. The next thing is push notifications. This is where the things get a little bit more complicated because you cannot just cut off one provider and start using the other one. Because the way it works is that mobile apps actually need to register a device in this notification service, and they will send a token to our backend, and then backend subsequently store the token, and once they need to receive, or if the backend wants to send a message to the client, it will pay this token that's been stored before, and it will send it to the client. And so the catch was obviously that when we were using the old Azure notification service, it was obviously using a different token. So we couldn't just like swap those, but we had to migrate it kind of in gradual way. So we would start gathering new tokens from HCM, but at the same time we were sending the notifications to the old service. So yeah, this took like I don't know. I mean, we had to wait for like a couple of weeks maybe until the adoption got like on a quite high number, and then you can just simply turn off the old solution because it's yeah. I mean, you can never expect like 100% adoption because there will always be users that are not going to update your app. So you just need to decide when it's a good point, when it makes sense to you to just cut out the old solution and only use the new one. So yeah, that was a little bit more interesting, I would say. And but we're not gonna talk about it more today. And the most important thing today, I think, is the migration of files. So as you can imagine, when you have a chat, or sorry, a dating app, it usually contains some profile pictures and chat. And in chat, you can also have like you can send photos, videos, or even voice messages. So we needed to migrate all of this data, all of these files to AWS S3, which is basically block storage. You can put there anything, and yeah, ideally without users even noticing that anything has been changed. So that was our goal, and now we're gonna look at the process of the migration. So basically, yeah, the whole process consists of two main steps. The first one is to stop uploading new files to the old storage, right? So that was as we were using pre-signed URLs, it was kind of easy to just change the way the URLs are generated. But for those of you who don't know maybe what pre-signed URLs are or what they are used for, so I can just quickly explain how it works. These pre-signed URLs are generated directly in cloud provider, so you don't need to do anything on your you just call a SDK on your API, and you just generate this URL, and then URL is sent back to the client, and client then will upload the file directly to this URL, which is URL that's pointing to cloud provider. So that means you don't need to edit on your API. You don't need to take care of anything like file handling or like some retries or storing files locally or dealing with, I don't know, streams if the file is bigger or something. So that's where it comes handy, and that's one thing. And the other thing is that it can be also used for reading, and especially when you have files in storage or in cloud, and you don't want to show them, expose them publicly, so you want to use this pre-signed URL. So client has to request this URL from your API, let's say, and they will provide you this pre-signed URL with let's say expiration set to 5 minutes. So this URL is only valid for 5 minutes, and once it's expired, you cannot access the file anymore. So yeah, that's basically what pre-signed URLs are for. So here's a little schema of how it works, but I think it's pretty easy to understand. So yeah, that was the first step. Actually, the only change that was needed was to replace Azure library with AWS, and that was we didn't change any endpoints or anything. So client didn't even know that there's a new URL. Yeah, so that's about the first step of the migration. So once this was done, we were sure that we're not gonna upload any new pictures or any new files to the old data storage, and now we could focus on migrating all of the old files to S3. So this is where things got maybe more interesting, because like this is like a set of steps, I would say, of how we were thinking about it. So the first step would be obviously to fetch profile photos from a database, URLs for the profile photos, and then we would download this file from Azure, upload it to AWS, and update URLs and in the database. We also use, like I said, Firebase, so we also had to update it in Firebase at some places. One interesting thing maybe is that when a user uploads a picture, we actually store like a few different versions of the picture for some performance reasons, because we store 3 sizes of the picture, and also blurred version. which is useful if you have if you have a premium version or if some things in app are only for premium users, so they won't see your face, let's say, or something like that. I mean, you get the idea. So yeah, that's basically uh, how it works, and can
Jozef?
probably move on to the next.
Please, can you wait for a second? Sorry for the interruption. I got the message that they need to fix Jozef's microphone, so I can fill that space with something I wanted to say at the beginning. By the way, I'm Michael. I'm backend lead, and I got disconnected at the very beginning, so I was not able to give you some intro. You basically know the Jozef who is speaking. I wanted to introduce him. He is our backend developer, a really good one, and also AWS solution architect. And while they fix his microphone, I would also like to mention that we are currently hiring to the backend team experienced Node.js developers. So we are open to everyone. So please feel free to apply if you are interested. We started a lot of exciting projects last year. There's also the reason why we are hiring. So feel free to apply. Okay, they are still fixing his microphone. I hope the sound will be better once they will be over. It will take probably 1 more minute. I hope you are enjoying the presentation. And let me check how it looks if the microphone is open.
All right, guys. I guess we're back. Sorry for some technical interruption. I think we can continue with the presentation.
Okay, thank you.
So I don't know what was the last thing you heard, but just to recapitulate in case you didn't catch the idea or what we were trying to do. So yes, for the first thing we tried to use pre-signed URLs. We had to change the library, so that was easy. And in the second part we were just trying to fetch all the user photos links from database, download these files from Azure, upload them to AWS, and update the database with a new data. Yeah, so it's also kind of important to think about when you're trying to migrate data. It's also a good idea to add some kind of flag, let's say, so you can tell which data or which rows or which users, let's say, were already migrated and which users were not. So, you know, in case you need to, like, let's say, run a migration again, or if you need to debug something, you can use this flag. So, yeah, that's what I mean. It's something which is like good to keep in mind. So, yeah, I think we can move on. So, with this setup in place, we can. All right, here we go. Yeah, so finally we're here. We can we can finally run the migration, right? So like I said in the beginning, we were using, and we actually still are using Heroku. So for that matter, it was kind of easy and straightforward way to just create a new process in Heroku. And that we would run the script and took care of the whole migration. So yeah, you can see that we were aiming really high with the number of profiles that were migrated within an hour. So now I would maybe like to ask you a question. What do you think, guys? How long was it supposed to take to migrate all the user profiles? Let me just know in a poll. And wait for a few seconds. I'm really excited to see what your opinions and what you think. All right. So even though number 700 might seem like a lot, or at least it did to me at the beginning, because I had nothing, to compare it to. So it seemed like a pretty decent or good number. I was kind of surprised when I did some math, just to realize that the numbers were actually kind of different. And yep, that's the actual result after I did like some math. I'm not good at math, but I think I actually was able to do that. And yeah, that was actually my look on my face when I saw this number, because I think you just cannot come to your manager and tell him not like, it's gonna take like 8 months for us to migrate all data from one storage to another. So yeah, well, that was not ideal. It was not ideal at all. So we had to think again and try to come up with a better solution. How to speed things up and how to make it more appealing, like the number. Yeah. So I think we can do better, and we actually did. We tried to introduce a so-called cluster, which is it's a library it's an internal library in Node.js, and which allowed us to run or spawn multiple workers or multiple threads, if you will, that will take care of data that will take care of the migration process at the same time. So if one worker can process like 700 profiles an hour, 2 workers should process at least the double amount, right? So yeah, with that mindset in our head, we tried to go for this goal. Yeah, but also one important thing that might come to your mind is that when we're running multiple workers at the same time, it might be like they might be interfering, right, to each other. So we need to find a way to somehow distinguish or make sure that the 2 workers won't process the same data. So we did that actually, and I'll talk about it later. So I just wanted to mention it, that it's not so straightforward to just put multiple workers to process the data, and that's it. So yeah, with that solution in place, we were actually able to shrink the whole number to a month and a half, which was really cool for me, and I saw we were aiming in right direction. So as you can see, it was actually, we gained almost like 5 times better results with introducing just 2 additional workers. And we were with this setup, we were able to process like almost 4,000 profiles an hour, which is really good. But still, it's still not good enough, right? You still cannot come to your manager and tell him like, okay, let's say this is gonna take us like a month and a half, right? So once again, we tried to improve the whole script like one more time. And whereas in the first improvement, I would say it was kind of like horizontal scaling. Sorry, I would say. Yeah, in this second attempt, we tried to to something which is better suitable for running such a load, I would say. Sorry. And that's actually moving to AWS, because Heroku it wasn't like really good in terms of offering options for scaling, and also it was kind of expensive, so we wanted to try something different. And so, yeah, that's why we moved to AWS, because like I said in the beginning, we were migrating all of our stuff to AWS, so it was like a obvious choice. Yeah, so we spin up a new instance in AWS. EC2 is just like a normal standard virtual machine in cloud, and yeah, we were able to run like 6 workers at it, and we were even not using the full potential of it, I would say. And with this setup, we were actually able to migrate. Wait for it. Yeah, we were actually able to migrate it all in like 1 week. So yeah, that's actually when I saw this number, I was really surprised and astonished by what we've accomplished, I would say, because we were able to migrate like 24K profiles within an hour, which is even more than what we were able to migrate with the first version in a whole day, right? So that was something really cool, and we were pretty happy with it. So we didn't really actually try to improve the script or try to scale it even more, because that seemed like a pretty solid number for a number of profiles that were migrated. So yeah, we didn't want to go further, because I didn't want to try the like how much the database would withstand, you know. So we didn't want to optimize it anymore. So that was good enough, I would say. So yeah, that's a pretty good sign, and I would say mission completed in this step, this point. So yeah, after one challenge was done, we were aiming forward against a new challenge, and in this case it was actually migrating chat files. So like I said, we use Firebase for chat, which is really cool, and it offers you some real-time options that is like crucial for application or feature as a chat is. So yeah, we were storing photos, videos, and voice messages in a database, or in this Firebase in chat database. And on your right hand side, you can see like an example of one of like a structure of a message in Firebase. And the most important thing is those last 2 fields, which is type of the message. In this case, it's a voice message, and also a voice URL. So it's like actually the pointer to the file which we need to download and upload it to the new location. Well, then I found out that we had some tables that were actually containing all the data that were stored in all the files that were stored in chat. So we had tables like photos, videos, and voice messages. So I thought, yeah, that's really cool. We don't need to go and try to fetch this data from Firebase in some way. We could just simply go over those tables and basically use the same script as we used for the photos, right? So I was like, okay, that's cool. We can do it in like no time. But little did I know that voice message tables wasn't actually there. Yeah, I was surprised by that. I didn't know why it was like that. But because when I saw photos and videos, I was like, okay, cool, we have everything stored in database, so we can go quickly through it. But then I didn't find any table for voice messages. So that meant that we would have to go through the Firebase one way or another, because we had no we didn't have any other way to find all the voice messages, right? Yep. So we had to do a Firebase thing for sure, because we didn't have any other option. So yeah, the thing is that in Firebase we have this collection called messages, which contains all the user conversations, and you have like messages / user ID 1 / user ID 2. So I was thinking like, okay, maybe we could go and iterate, through the whole collection and try to find if try to go through all the messages, and if the message is a type of either photo, video, or voice messages, we'll just download the URL, upload it to the new location, and update the message. So actually, pretty similar to what we did with profile pictures. So this is something I came up with in the first place. It may be worth of saying that we were using real-time database, I think, which is like the first version of real-time databases offered by Firebase. They have a newer version which is called Firestore, which is more capable and has more features, but this one didn't. So we couldn't use. I mean, we didn't have many options to go with. So this is what we came up with. It's just like a simple script, to iterate through the whole collection, and only limited to two files at a time, or to record at a time. So we would fetch the first one, which we were gonna migrate or process, and the second one was only for used only for as a pointer to the next iteration. So yeah, I was thinking like, okay, this is pretty cool, right? We have a pagination in place, so we can process really big chunk of data, or really like the whole database, because we still are gonna only fetch two fields at a time. But well, not really. It ran smoothly in dev. Sorry, I can tell you that, because when I launched the script on our development environment, it was done in like, I don't know, 5 minutes maybe. And I was thinking like, okay, cool, this is cool. It works. It seems that it's working fine. We don't have any issues. No one was complaining. I mean, like from us developers or from some QA and some people that were using develop version. So everything seemed to be working normally. So we thought like, okay, cool, that's probably it. Let's move it to production, and let's run it again, right? Well, no, it's not that easy. In reality, pagination doesn't work that well, but as I learned. So it means like, if you have a smaller collection, it works just fine, I'd say. But if you have like a collection where it's like, I don't know, maybe millions of records, as you can see right here, we have this function order by key, which is required if you want to do pagination. So we had to order everything in order to actually start paginating. But it doesn't work well, like I said, on large data sets. So that's not a good thing. Again, I don't know. Maybe it's better in Firestore now. I can't really tell. But at that time, it didn't work. Yeah. Also, there's no way of some kind of lazy loading. So if you fetch one field or one document, it fetches all the child data as well. So it means, in our case, when we fetched one conversation, it would fetch all the messages in the conversation. So there was no way to paginate again. So that was kind of like not good, and so we had to rethink our solution once again, because there was no way. I mean, this just simply didn't work, right? So we had to find a different way to do it. So yeah, I was thinking like what would be the best approach, and we actually ended up using our relational database once again, where we would fetch all the users, all the user IDs, and then we would go through all of their conversations. So we also have this other collection in Firebase, which is called message conversations /user and -user ID. So what this gives us, or I mean, this collection stores only all conversations for a given user. So it's much more like a smaller collection or document in terms of size. So yeah, we could actually use that and go through all of the users, then go through all the conversations for a given user, and then again go through all the messages in the conversation. So yeah, with that being said, it actually worked pretty well. Yeah, I think we ended up running processing the whole chat in like a few days, and there were no major or bigger problem with it, I think. So this brings us to some issues maybe or takeaways that we've learned along the way, and that I would like to share, because I think it might be useful for you guys to know. And I also like to hear from you also some feedback maybe, or if you have an experience with something similar. Yeah, so the first thing we realized when we were running the script for a few days, that it sometimes just the worker just exits for some reason. Sometimes it was obviously because of some error that we've fixed, but sometimes it was just like some random thing. I don't know, we didn't really go much into the details because it wasn't necessary, as it was working just fine. So what we came up with was just a simple solution to implement retries, or respawns. So once the worker goes down, we just spin up a new one, and this way we can keep up the desired number of workers at all time. Yeah. Also, the other thing is, when you're migrating data, it might happen that some rows or some users or whatever it is might not get through, or might fail for whatever reason. Yeah. Sometimes it might be like some error that you're anticipating, and you'll have some logic in code that will catch this error and handle it properly. But sometimes it just might happen that this is some error that you, I don't know, maybe don't know how to handle at that time, or it's just something bad. So you can't really process this type of data. So for this case, it's really good to have a way to store those like erroneous files or rows or whatever it is, because we didn't have this from the beginning, right? Obviously, and what happened to us is that we were, I don't know, migrating some data, and then after some time we learned that there was like some chunk of data that just didn't get migrated, but we couldn't really know what files didn't get migrated, because we had no way of like storing them somewhere. So what we had to do was just to basically run the migration again, and this is where this flag I was talking about earlier comes handy, because with this you can simply check if the file was migrated, and if it wasn't, just move on to the next one. So yeah, I think it's really good and important to have a way to store or save or somehow log errors and some files, or, I mean some data that couldn't be processed. Yeah, also Heroku is kind of fun when it comes to money and performance, because it's really good to start if you have some project that you want to publish on the internet, and you don't really want to spend time setting all the different things about networking and I don't know, some policies and stuff like that. So it's definitely a good way to start with Heroku if you just need to spin up your project in literally no time. But once it gets more used, I would say, and when it gets more traffic, it can get really expensive. And that's why I personally wouldn't go to it when it comes to like a project that it's running in or it's going to production, or it's going to get more traffic. Because in the beginning we were trying to migrate run the script in Heroku, right? And we started with Dino, which is like kind of compute unit, I don't know, that's been running our code, and we started paying like $25 a month for just 512 megabytes of RAM, right? Which is like ridiculous, I would say. Then we had to scale up a little bit because the script wasn't performing well, and that's where the next step, or where the next iteration of their pricing model is, and it's like 1 gig for $50. So it's really not good if it comes to scaling, I would say. And that's why we eventually moved to AWS, where you can get an instance like we did for in this case it was like T2 Medium, which offers you 4 gigabytes of memory, and we ended up paying like around $30 for a month of running. So that's that's really cool, and I would definitely go for AWS, or I mean, not, it doesn't have to be AWS in specific, but for some cloud provider where you can get you can get more control. You know, you can do like more complex setups. It gives you more options what you can do and how you can improve the whole process and the whole environment of your application. It also brings you a lot of features and also better pricing model. So they say that you only pay for what you use, which is really cool, and you cannot say that about Heroku, because you still pay like a fixed amount of money. And I would maybe also mention one more thing that we were considering, and it's VPC endpoint. So VPC is basically like like your private network in cloud, where you can store all your like your servers, instances, and basically everything. So it's like your private network in a cloud. And if you we were running our script inside this EC2 instance. And what the script was doing, as I already said, it was downloading data from the internet, from Azure, and then uploading them back to S3. But it does that, via the internet, right? Via the public internet. But what VPC endpoints allows you to do is to use an internal AWS network for all the networking that goes between your EC2 instance and S3. So this was something we were considering, as it would bring more speed, I would say, as we wouldn't need to go through the public internet once we had file locally in our instance, and we could directly move it to S3 through the internal AWS network, which is obviously much more performant and quicker than going through the public internet. Also, I would maybe mention one more thing. Like I said, I think it's good to start with Heroku, but if you plan to maybe one day moving to something better, or maybe like some proper cloud provider or whatever, it's good to keep like some things in mind and to prepare for a migration at one day. I mean, what I'm thinking of at like one specific example is that when you create a new app on Heroku, it gives you a URL, right? So it's something like my super cool app.herokuapp.net, I think. And if you use this URL in your app, let's say, or yeah, basically in app, you can't really make sure that this once you try to migrate it, you can, I mean, obviously publish a new an updated version of the app with a new URL pointing to your new server or anything. But there will still be this older version of the app which is using this old Heroku app domain, and you never really have you will never have a chance to actually get rid of this. I mean, you could obviously cut it off, but it's just like, you know, for some users it might happen that from one day to another their app just stops working because you decided to migrate your servers to a new location and the URL, the API URL just changed. So yeah, what I would suggest is just like a very simple solution for that is to just use your custom domain name, so you can easily transfer DNS records to anything else, and you're not like tied to the Heroku domain, which might be, I think, really a problem in some cases. Yeah. Yeah, and one more thing that was kind of interesting and surprising, so I thought it was like worth of sharing. Is this graph. What it actually is, it's like a utilization of memory on our EC2 instance when the script was running. And you can see like all these little bumps and drops are when the worker thread actually either started or stopped. So you can see it was just somehow trying to keep it in a linear way. But then there is like this really big spike and 2nd of May, I think. And there was something really interesting because I didn't really know what to think of it and what was the reason, what happened, if it was, you know, running smoothly for a few days before, and then all of a sudden there was like this really huge spike. So like the first thing that comes to your mind maybe is just to try to SSH to your instance, right, to see what the problem might be. But yeah, I wasn't actually able to even log into SSH as it's shown on graph. All the free memory was used, so there was actually no place for anything to happen. So I had to just go directly to AWS console and restart the instance, and then log into it and try to find the issue. Then I found out that the whole disk and everything was completely full with some data, but I didn't know what this data could be because we weren't storing anything. And then I somehow came to the point where I learned that we were using PM2, which is like a process runner for Node.js applications on the server. It takes care of like running your applications when you, I don't know, like basic process manager stuff. And I learned that it stores logs by default. That was kind of like, I don't know, it wasn't even surprising for me because honestly it was my first time using the library. But yeah, I learned that it stores all the logs by default. So the easy solution for this and easy fix was just to disable logging, and that was basically it. And yeah, so I think that's I just wanted to mention it as it was like something that it's interesting, I think. Also, some other things that I've learned from my colleagues in one of the PRs when I was trying to merge this feature is that something I wasn't really thinking of in first place, and that's that you should probably obviously use streams for downloading and uploading data or the files. So this way you don't need to download the whole file locally to your computer or to the server in this case, and then just start uploading the file to the actual cloud. So yeah, we used streams, which was one of the things that I didn't really think of at the first place. And also the other one that was even more interesting is that as we were running this script in like some batches, let's say, in like we were migrating, let's say, I don't know, 50 users at the same time, and all of these users could have like multiple photos, and each photo has like 4 versions, right? Like we said, so it could like really simply blow up in a thousands of pending promises as stated in the comment. So we had to find out like some way how to limit these numbers of promises that can be run at the same time. And this is actually what we came up with. It's just a simple solution that goes through an array, and you provide a callback function, and it always calls these callback functions, which generates promises only on a smaller chunk of data. So even if you provide there like a 50 or 100 files in an array, it will always process only like, let's say, 5 at this specific example, 5 promises at the same time. This is really good like for memory optimization, but obviously it's more time consuming because I mean, if you do it like synchronously, it just takes time. So I think it's always good to think of it what's the best approach or what works better for you. But in this case, this was the really simple solution that we invented. We came up with, and just later on I realized and learned that there is something similar already implemented in Bluebird. For those who don't know what it is, it's just like some Node.js library that deals with promises. I didn't know about the library either. That's why I came up with this custom script, but it's actually already implemented in the library as well. Yeah, and as I was saying about the process orchestration in the beginning, it's now's the time for going more into deep with about that. And what is it about? It's when you have multiple workers that trying to access the same data or the same data source at the same time, you need to find a way how to, tell like, okay, worker 1 will get this portion of data, worker 2 will get this portion of data, and you need to make sure that those workers want to be processing the same data. So we came up with this little library, which was originally just a piece of code that was part of the migration, but later on we actually saw like it could be maybe extracted and put into a separate package, because it might be useful for some other use cases or for some other people as well. So that's why it's on GitHub, by the way. But yeah, so what it does is that it does basically what we were talking about earlier, like it spawns and manages workers. So in case some workers fails or something, it just spawns a new worker for you automatically. It also orchestrates access to shared resource. That's the most important thing it does. And it also comes with some other features that are handy, I would say, like for example, picking up unprocessed payload, which is something we could compare to dead letter queues. So in case that some worker fails for some reason, and it keeps some data that hasn't been processed yet, it can store this data. The library can store this data, and the next worker will pick it up and try to process it again. And there's also like some limit, obviously. Like, so if some data cannot be processed, like, I don't know, maybe 3 times in a row, it just stops trying to process it, but it keeps it in the queue. Yeah, and also this kind of like, I don't know, it's never been really tested, like the distributed lock option, but it should be possible to run the script on multiple machines with one shared Redis, which is used for locking and also for storing all these payloads. Yep. So that's here's an example of how the library works, and basically it consists of 2 functions that you need to provide. Well, where the first one is set fetch next, and then there's a set handler. So what those functions do is the first function, the set fetch next, is you provide a callback there as a parameter, which contains your business logic and everything you want to do with the data. And no, sorry, it just contains the logic for fetching data. Sorry, for fetching the data from the database. And then there is a second function which is called set handler, which actually does this business logic for you. So what is a difference between those two, or why it needs to be like that in these 2 functions, why it cannot be together, is that the first function, set fetch next, is the worker makes sure that it's always called just once at a time, and this way we can assure that it's that 2 workers cannot get the same portion of data. But set handler can be called and is called like on all workers together. So multiple workers can process their assigned portion of data, but once they are done with processing, they will need to like wait a little bit for this master node, let's say, which will call our set fetch next function, and will assign them a portion of data that they can work on. So yeah, that's how it works, and I think that's it. Yeah. So guys, any questions? Now we can welcome our secret guest.
So a little bit more. Okay. Can you hear me? Yeah. Well, hello everyone. I'm Alan. I'm here to be your moderator. Do you guys have any questions? Because I have some.
Cool.
I think I'll start with one of mine. So while we were talking, I was pretty curious about like how you guys handle, if it was that easy to handle like the assigned URLs.
Yep.
Because I don't know, like you were using GCP before?
Azure.
Azure. Like, was like the API the same? Did you guys have like much trouble dealing with like different, images with like different URLs? How was that?
Yeah, that's a good question. And now that you asked this, I actually realized that maybe I lied to you guys a little bit, because there was this little tiny issue. But I mean, yeah, the library was different, but it on the outside, the app supposedly it wasn't supposed to, to see the difference, but there was a difference because
It's always like that, right?
yeah, right, because the apps were yeah. So what we basically did is that we just changed, like I said, the library, like this SDK package from Azure to AWS, and just
AWS.
called a different function, and that was it. We still got a URL which was sent to our API endpoint that was existing before, so nothing changed, no fields were added or removed. But when the apps tried to upload a file, we realized that there was like some tiny issue, but it was only with one type of data. I'm not really sure what it was, but I think we weren't able to post or upload videos in chat.
Classic.
Because of some
Probably
there was
cars
like
or-
some extra header or something
Yeah,
being
parts,
sent
probably.
being sent in, I think in the older version with with the older version which was required by Azure, and so we were trying, the apps were trying to send these to AWS, and AWS was like having some problems with some signature or something because there was something that they didn't expect.
They didn't expect, yeah.
Yeah, but overall, I mean, like, I would say it was pretty easy to change. Like, this was the only problem we faced.
Good, awesome. Yeah, and when you said like about the workers, did you use like the new Node.js like worker threads, or was it like the cluster that's like another library?
Yeah, well, that's something that I was thinking about as well, but like a few months ago, because at the time when I was writing the migration, it was like last year in March, I think, or April. I didn't really, know what those packages were about, and I know we were using cluster for some like for spreading some load on the API. So there was this package used, and I just copy pasted it kinda into the new file, and I started writing logic for a script, and I was trying to see if it really spawns two workers that can be run at the same time, and it worked. So I didn't really care anymore.
So you're like, yeah, well,
Honestly,
if it works,
if
it works.
don't touch it, right?
Exactly.
Yeah, so I just did that, and it worked. It still works fine, and to answer your question, it uses cluster. But yeah, I know there is some I don't know if it's new, but there's some package called worker threads, I think. But I don't really know a difference, to be honest. So
Yeah, I think like the worker threads, I don't know like the other one, but the worker thread is not like native in Node.js, that it like you don't need to install anything, it's in the standard library.
Yeah, but I think cluster is in standard library as well.
Yeah, I think so.
Yeah, but I don't know what's the difference.
Yeah, I think because like cluster is spawning, if I'm not mistaken, like another instance of Node.js.
Yeah,
and the
be.
worker is
Could
like
be.
a thread, like say,
Could be,
so you can like do multi-threading.
Yeah, that might be right. Yeah.
So, but I also don't know the difference.
I mean, I still
used
don't know if it's like what is more, what is a better solution in this case, if I should go with worker threads or stick to the cluster.
Yeah, but I mean, if it works.
I mean, it works, right? And that's the important.
Yeah, but like if someone like out there start doing the same project, I think it would be worth it to check like what is the difference between the libraries.
That's for sure.
And later tell us, because I haven't.
Yeah, I mean, if I was doing the script or the library, if I was writing it now, I would definitely check it. But just because I know there is, like these two packages that do a similar thing, and I don't know what the difference is. But back then I didn't really, pay much attention to it. As I said, we used cluster, so I went with it, and it worked.
You had to choose one and it worked.
Yeah,
and now that you have something that works, you can try later something else.
Yeah, but you guys can open a PR pull request, and you can make it. You can make it better.
Like do it,
guys.
And like I saw that you guys were using EC2.
Yep.
But did you consider like, I don't know, using like lambdas or something like that? Because I don't know if that would be a good fit, but I was like, what if?
Yeah, I don't know if it was a good fit. Probably not, because the main difference is that the Lambda is serverless, and the main I mean, it can run only for like, I think 30 minutes max. I'm not sure now, but yeah, I mean, it's just like for, these short requests. Or if you,
Short-lived, yeah.
I mean, for example, if you upload a file, we use Lambda for generating those three versions of a file. So if a user uploads a file to AWS, it automatically triggers a Lambda function which generates all those different sizes and blurred version as well. So we use Lambda for that. Yeah, but in this case we needed something that was running constantly for a few days, as we could see on the chart. So yeah, that's why we went with a EC2 instance.
Perfect, makes sense. Nice.
Yeah.
So I still had one more, like regarding the pagination. When we were talking about it, we were talking about like the pagination from Firebase or from the like your own DB,
Well,
or both. At the
both.
same time? Okay.
Both, yeah, because like I said, in the first round or the first attempt to migrate chat, we just wanted to simply paginate through the entire messages collection, but it was just too big.
Too big.
And
and they use like offset, if I'm mistaken, right?
there is only this, like, you can have a start after. There is a function start after, and you need to provide like a reference to the previous document you see, So that's what we try to do. So we always wanted to just fetch only one record sorry, two records, because one is for it was not start after, but start at. Sorry. Yeah. That's actually the reason why we had to fetch two fields or two records. So the first one was to migrate it, and the second one was just for a reference.
Just for
so
reference.
in the next in the next iteration, we could actually process this next one, and also fetch the third one, which would be processed
like
again.
Looking ahead.
Yeah, exactly, something like that. But I know that in Firestore, it's which is like this newer version of they provide, there's a little bit more options. So I think it could work differently, or maybe even better in Firestore.
Nice. We still have some questions from our audience, so
Sure.
I will ask them. First, what was the bottleneck in the migration process?
Well, I would say it was just like, if you need to download files, it just takes time.
Yeah.
And yeah, I mean, this was probably the only bottleneck, that the one single process wasn't able to process more than 700 of files.
Yeah.
Because when I was checking the logs, it seemed to me like one file or one user, let's say we had like 3 photos, in reality it means he had like 15 photos, because we store like 3 sizes plus blur plus the originally uploaded one. So if a user has like 3 photos, that means we need to download 15 files that need to be uploaded to the new location, and also update the database. But I mean, database is just not really. But basically, I think the bottleneck was to just downloading the files and in the network. I think I didn't really go like deeply into trying to find out the bottleneck, because I just tried to make it better. So I just tried to implement multiple workers that did the job.
And they did.
And they did, yeah. So I didn't really care about some micro optimizations.
Yeah, and like the images, I think they weren't like that big, so I don't think the network would be the bottleneck in this case. There are like some videos, I think, might be.
Yeah. So that's what I'm saying. I don't know if there is like some something that I would like specifically call like a bottleneck we try to fix or avoid. I would just say it was just like I don't know, just one single Node.js process wasn't able to migrate more than 700 profiles on average, right?
Yeah, it was like more bound to like the CPU, the memory, than like I/O and everything.
The thing is that I also didn't try running just a single worker on EC2. It could be interesting to see how's the difference between in terms of performance between Heroku and AWS. But yeah, I mean,
You did what you could.
Yeah, I mean, it just ordered.
Perfect. We have one more question. What was the order of magnitude of the size of those data? So how big was like your data set?
Yeah, so I think I had some written in my notes. I just didn't mention it, so I can tell it now. It's when I was checking the storage in AWS, it's something like I think 1 terabyte of data for search and something around 2 terabytes for search and 1 terabyte for Grizzly. So it's kind of decent amount of data. I don't know. I never really had anything. I've never really worked on anything on such big scale before. So it was like a pretty lot for me.
Yeah,
So
and like
it was kind of a challenge. I don't know if
You
it's a
can
lot
imagine.
or not.
sounds like a lot.
Sounds like a lot.
And because like the image they're small, so that's
Yeah,
a
yeah.
lot of images.
It is. Yeah.
Great,
So
great.
yeah.
But like now that like you've gone through all of it, if you would like start like a new project that you had like the same problem, do you think you would do something like differently or approach the problem like differently from like the final solution you already
Yeah.
have? Would you do something different like based on the final solution? Or you think like, well,
Yeah, I would maybe focus more on logging, like I said, and because it also depends on logs. Because if something goes wrong and you don't have any logs, it's just like you don't know what
You don't know what's
you
going
don't know what to
wrong.
do, right? So it happened to me actually a couple of times that that the script just stopped and I didn't know what happened. So I had to add some logging and then deploy it again and try to run it again. Because in development, when you try to run the script locally, you have like, let's say 3 dummy files or 3 dummy users, and you prepare the data, so you basically know what to expect when you write any code. But once you get into production, and there might be there is a different set of data, and you don't know what to expect. And there might be like there were cases when there is like we have this object or JSON file where we store like small, medium, and large, and you wouldn't expect that there could be a JSON file, but there would be like small null and large null. So the object would be there, but the values weren't there.
They weren't there.
It was just something you don't really think of.
Just production things.
Yeah, exactly. So that's so yeah, definitely logging. And what else? I don't know. Maybe try to once like I said in the presentation, once you get some data that is corrupted or failing for some reason, it's really good to store it somewhere, so you don't need to go over and over the same data again, because that happened to us a few times.
Can you imagine?
I mean, there was like we had again write some scripts. Like there was like there was like condition checking if the URL is already in AWS, and if it is, we just skip the file, so
Skip the file,
it doesn't happen that the same the file that is already in AWS, it gets there again, like duplicated. So yeah, this was
It's a lot of work.
it is. Yeah, I mean. So yeah, definitely logging and trying to maybe store failing
Failing,
files.
yeah. So you can like
files, whatever.
inspect afterwards what went wrong. And
Exactly. And maybe it's better to store it in a way that is easily processable by the computer.
Yeah.
So you don't. It's not like you would just store that ID 13 failed, but it would be just like some, I don't know, maybe JSON or something. So you can just then read all the data from, let's say, Redis or whatever, and just run the script over this data again.
Always better when the machine is doing the work, right?
Especially when you have like 2 terabytes of data. You don't want to do it manually.
Yeah, not at all. And one last thing I have like for myself, I'm really curious because like for me, one thing that's really expensive is like the price for the outgoing, because we were like in Asia, everything started there, and we were like moving to S3.
Yeah.
How was like the price from like
Well, honestly, I don't really know.
You're like, no, don't wanna see.
I mean, because I don't really I didn't really have an access to those numbers back at the time, and so I don't really know like the exact numbers, but I know it was a lot because we were paying like overall we were paying like I don't know if I can say it, but like
Some money.
a lot of money. Yeah. So
Was like in the thousands.
yeah, it was in thousands.
Wow,
So.
that's some
But
money.
it's not only for because of data of storage, right? But we
Yeah,
had
was
some
everything
we had some other things, and also we had some like I said legacy things that were running but weren't in use anymore. So that's why we just wanted to somehow shift away from it and migrate all the data and then just shut everything down.
Makes sense.
So we could start
Like set down, set on fire, and like
yeah,
go home.
exactly.
Excellent.
So yeah,
Perfect, perfect. I will see if you have like any more questions for the audience.
sure.
Yeah, I think that was the question. So if you guys have any questions still, please. We still got some time. If you guys don't, well, I think that's it for me. So again, thank you very much. It was
Yeah,
like
thank
a
you guys
really
for coming.
good talking.
Thank you.
And yeah, let's see. I'm curious about like how some people would do it. I want to see some pull requests.
Yeah, I would love to see like a different view, or hear a different view of on that topic as well.
Perfect.
Okay.